Hello, welcome back to another video. Today we're going to be solving this problem from the IB Math AHL M25 session, paper 1, section A, and it's an 8-mark question. And it says we have a homogeneous differential equation, an initial condition, and our task is just to solve it and show that the solution is this. Right, so we can start by writing out the equation. And they've given us a substitution we need to make, y equals vx. Now, the main part of the homogeneous differential equation is to do this step right here. So we have y equals vx. If we take if we differentiate both sides, not necessarily with respect to anything, but if we do like this, dy, this is equal to the derivative of this plus the derivative times this function plus the derivative of this function times this function. That's the product rule. We could actually do it in terms of x. So we get dy dx is differentiate v with respect to x. So you get dv by dx times x plus differentiate x with respect to x. That's 1 times v. And if we multiply through by dx, we get dy is equal to x dv plus v dx. Now, we need to remember this equation. It's quite important, and we'll use it in the next steps. But now we substitute our y equals vx into our original equations. So we get dy over dx is equal to, and wherever we see y, we change it with vx. So x minus vx over x plus vx. Right? So now what we do here, we can cancel out the x's because there's an x in every term on numerator and denominator. So we get 1 minus v over 1 plus v. I hope everyone's with me now. Finally, we can do our separation of variables. So dy by dx is equal to 1 minus v over 1 plus v. And we can actually rewrite this as dy equals 1 minus v over 1 plus v dx. Now, we have our dy. We can just plug that in here. X dv plus v dx equals 1 minus v over 1 plus v dx. And just as in any separable differential equation, we need to separate the variables. And we can actually do that by moving the dx terms to this side and the dv terms, keeping them on this side. Or we can actually move this term here. So, right. So we get minus 1 minus v over 1 plus v dx is equal to minus, or plus v dx. I'll keep this here. Like this is equal to minus x dv. And we can actually use this minus to flip these terms. So we get 1 minus v over 1, or it's the same thing, sorry. But yeah, now we can get a common denominator here. So if you multiply v by 1 plus v, you get v squared plus v minus 1 plus v, because you have the minus distributes. So minus times 1 becomes minus 1, and minus times minus v becomes v. Right? So 1 plus v dx is equal to minus x dv. And it'll become pretty clear why I've kept the minus on this side rather than using it to flip the variables here, or flip the sides. Now, what we can do, we can simplify this expression. So plus 2v minus 1 over 1 plus v dx is equal to minus x dv. And we get, if we divide both sides, we get divide. If we move x to this side and move this term to this side, we will get the following equation: dx over x is equal to 1 plus v over v squared plus 2v minus 1 dv. Great. Now, we've separated the variables. What do we do now? We integrate, because we have terms with d on both sides. We can integrate like this. This one should be quite simple, right? What's the integral of dx over x, or 1 over x dx? It's just log absolute value of x. So minus log x is equal to this integral right here. And the question is, how do we integrate this? Well, take a look at this denominator right here, right? We have v squared plus 2v minus 1, and we have v plus 1 on the top. What's the derivative of the bottom function? It's equal to v squared, or v squared plus 2v minus 1 becomes, if we differentiate this, 2v plus 2. Or, if we factorize, 2v plus 1. And what do we have on the top? We have a v plus 1 term. So, we can make a clear u substitution here, and this will help us actually, this will make the integral very easy to solve. So, let's do u equals v squared plus 2v minus 1, and du equals 2v plus v dv, or 2v plus 2 dv equals 2v plus 1 dv. If we simplify this, we'll see that if we divide by 2 on both sides of this equation, we'll get du, 1 by 2 du, is equal to v plus 1 dv. And if we look here, this is exactly what we have here, v plus 1 dv, right? So, minus log absolute value of x is equal to integral of, on top, what is it? It's 1 by 2 du, or sorry, I'll do it on the end. It's 1 over u times 1 over 2 times du, right? Because 1 over 2 du is equal to v plus 1 dv. And similarly, it's the same integration process here. Minus log x is equal to 1 by 2 log u, and we'll add a plus constant term. And of course, the plus constant term would be on both sides, but we can absorb this constant run from this side onto this side. It doesn't matter. Okay. And we'll plug it back in what u is. Plus c. Right. And since we have a log here, we can actually put the c. We can put the c on this side, actually. It doesn't matter. And the sign doesn't matter because we haven't even determined c yet. It could be negative, it could be positive, whatever. It doesn't matter. And again, we can take the log of this constant, and it still wouldn't matter because we haven't even determined the constant yet. So we can just say it's equal to ax, because log x plus log a is equal to log ax, right? And c could be log a, whatever a is. So 1 by 2 log v squared plus 2v minus 1. We have logs on both sides. We can simplify this. So we can move the 2 to this side. Minus 2 log ax is this. And we get log ax minus 2 is equal to log v squared plus 2v minus 1. And we can cancel the logs. And essentially what we're doing here is we're exponentiating both sides, but it doesn't matter because we can just cancel the logs. So 1 over a squared x squared is equal to v squared plus 2v minus 1. This is our solution, but we need to show what it asks, right? We need to show this condition right here. Again, what A is has no impact. Like A could be, if A squared is a constant, then A, we can say that B is a constant, right? Which is equal to A squared. We haven't even determined either of those, so this is fine to do. This is allowed. We can say that we can replace A squared with B, and we'll actually be doing a similar step for constants soon. So another important point to note is you don't need to perform the same operations on the constant unless they can change the value of the constant, right? Or where the constant is. Like I can't do all these steps with that constant and add a constant at the end. The constant could be, it could be what multiplies to another term of function. So 1 by bx squared is equal to v squared plus 2v minus 1. Y equals vx implies that v equals y over x. We can substitute that here. So 1 by bx squared is equal to y squared over x squared, which is v squared, plus 2y over x minus 1. And we can move the 1 to this side. So 1 plus 1 over bx squared is equal to y squared by x squared plus 2y over x. And we can multiply through by x squared. So 1 times x squared, 1 by bx squared plus times x squared is 1 by b equals y squared plus 2xy. And all I'm doing necessarily here is multiplying by x squared. Like so. Finally, we have our thing. So x squared plus minus 2xy minus y squared is equal to minus 1 by b. And again, doesn't matter what minus 1 by b is, right? All we're doing is saying that if b is a constant, right, then 1 by b also has to be a constant because you're just inverting it. It's still a constant. And minus 1 by b also has to be a constant. So we can just replace this by c. Okay, and to figure out what c is, we use our initial condition. Y equals 0 and x equals 2. X squared minus 2xy. So we have y of 2 is equal to 0. Right? If we plug in x equals 2 here, what do we get? 4 minus 2 times 4 times 2 times 2 times 0 minus 0 squared equals c. These terms are all 0, so c equals 4. Finally, x squared minus 2xy minus y squared equals 4. And this is our final solution from that differential equation. And if you if they don't give a show that question, actually, you should always verify, or you don't have to, but if you are unsure, you can verify that the solution you have is a solution of the differential equation by just differentiating it and checking if it works. In this case, we don't need to because we've gotten the show that, but that's just a general tip if you're unsure. But yeah, that's this question. That's in free 8 marks on paper 1. Good luck on those taking the November exams and eventual other exam sessions as well.